All right, so before I take you guys' question, I would like to address a few points, and then you can definitely ask me follow-up. For your programming test number 2, it's not very likely you will get the result before the exam day on Sunday because one of the TA, he's also an undergrad student, so he will not be able to return back to work until tomorrow, maybe the exam. So we'll return the result about your programming test number 2 sometime next week, and then we'll give you some time to think about if you want to get regraded, like a programming test 1. But my impression is programming test 2 is rather similar to what you did for the practice test 2 and also lab number 3. So hopefully you'll be very straightforward. Okay, so for the result, most likely we cannot return back to you before Sunday. However, I would suggest for programming test 2 specifically, what you should really go over is about the part 1. Okay, so part 1 of your lab number 3 and also your practice test 2. And when I say part 1, so that means mainly about how you can define the context using quantification, defining mathematical objects. I would say in the actual exam, maybe I'll talk a little bit about your exam. I already sent it for printing, so the question's already fixed. I can answer some general questions if you have. But I think a very big part you should really focus on will be how to specify things like invariant properties for mathematical variables. Okay, so this is definitely a very big topic which we spoke about throughout the course, right? We started with the math review lecture where we talk about how you can do quantification, nested quantification, and also we did lab 1, lab number 2. Actually, I think almost basically every lab and every one of your programming tests does have some kind of involvement about specifying invariant properties. In the exam, you will be asked to do something very similar. I do have some questions that definitely require some thoughts. So I would say during the exam, you have to stay very calm and then think about how things should be done. Okay, that's about programming test 2, and it's a very big topic. You want to make sure you definitely, the best way to really get prepared would be to go over all the materials related to specifying predicate properties for the exam. Okay, and let me, do you guys have any follow-up to this before I talk about maybe a little bit about the actual exam? I can give you some answer to the most frequently asked questions. Okay, let me talk about it before you ask me some follow-up. So the actual exam, you guys know pretty well, you got 3 hours. And also you're allowed to bring your data sheets. And guys, please make sure you actually adhere to the rules on the guide, right? Only computer type, no handwritten. And the font size should be no smaller than 10 pt. Okay, but you can put anything you like on the sheets. I would definitely highly recommend put the inference rules that you think you might need for the proof. You definitely be expected to do some proof. Okay, and if there's any proof obligation, for example, any proof obligation rule that you think you might easily forget, you can put one. For example, invariant preservation could be a very nice one because I think almost every proof obligation rule has very similar hypotheses. So you may want to get that one and then to really make sure, remind yourself what might be the different hypotheses you have to put for different proof obligation. All right, so these are just 2 examples you can put on your data sheets. Okay, and then we got 5 problems for you to solve for the exam for the 3 hours. I believe only one of them has a single part. It stands by itself. So that one there, it's just a single question. For all other 4 problems, they're kind of related, or they simply got multiple parts. So you definitely have to somehow time yourself very well. So I would say you'll be given the entire booklets for the questions. I would say flip all the pages, maybe spend the first few minutes looking at how many questions you got, and get a feel about which ones you feel more comfortable answering right away. I would say do that first. You got 3 hours. And yeah, so the 5 problems. And then overall, I'm not sure if this may help, you got 250 marks in total. So the total mark is not 100, it's 250. Of course, once we grade your exam, the marks will be calculated into the percentage out of 250. That's what we'll do. Okay? Yeah, do you have any follow-up about the exam you want to know? If I can answer, I'll answer. If I cannot, I'll say I wouldn't answer. Anything you'd like to ask. We can handle maybe some administrative stuff first, and then you can ask me a concrete question about the any of the course material. Anything you want to ask? Okay, maybe I'll give you some time to think about. That's okay. Meanwhile, do you guys have any questions about the material? Yes? Yeah.
Could you give us, for example, a way you can ask us about that?
Okay, sure. If I understand your question correctly, let me see. Let me get to the diagram first, and then we can go from there. Okay? Okay, let me first of all go to bridge controller. And then, yeah, something about simulation, if I heard you correctly. Give me a moment. I'll take some time. Okay, getting there. Okay, getting there. Oh, I may have, you know what? I may have gone past already. Give me just one moment. I'll definitely find it. Sorry, bear with me. Oh, this one here, right?
Yes.
That's the diagram. Okay. I do believe I got a better, like a larger one. And then I'll move to my iPad in just a moment. Okay, that's a good one. Okay. Okay, so I think for this one here. Okay. Let me just get prepared, and I'll switch to the iPad. Give me a moment. Okay, over here. So you just want some example ways about how I may ask questions about this diagram, right? Okay. So a very typical one, which is the simplest one I can ask would be, let's say, for example, I would say, let's say concrete event, let's call this EC for concrete. I got the corresponding one, EA for the abstract. So the first one would be, if we actually got this particular commuting diagram that's established for both the abstract event and the concrete event, how do we call that formally? Do we say EA is simulated by EC, or do we say EC is simulated by EA? Right? That's one question I can ask. Okay, I'll put it down. You can look it up. It's on the slides. So question one is EC simulated by EA, or EA simulated by EC, right? I'm pretty sure you can find the answer easily, okay? Another question could be, you can simply describe what's the story behind this particular diagram. Maybe without writing down, I can just talk briefly, right? You can say, starting with an concrete pre-states over here, because the W is all the concrete variables. Starting with this particular states, we are trying to make a concrete transition by taking the occurrence of the concrete events. And we're going to terminate and end up in this particular concrete post-states, taking all the effects of the transition, of the action. And then we want to make sure there is a corresponding abstract transition over here. And the abstract transition will also start with some pre-states that's in the abstract model, and also some abstract post-states. How do we relate? Specifically, for example, the abstract pre-states and the concrete pre-state, how do we relate them? We relate them using a particular kind of invariance called linking invariance. We mentioned that in the slides in class. So linking invariance is basically kind of an invariant condition that will involve both the abstract and the concrete variables, right? So we try to link the abstract and concrete pre-states, and also we try to relate the abstract and concrete post-states using the same linking variance. So that will be the story. So I think these are the very typical questions I might ask, okay, just to show your understanding, right? But I think in the actual exam, you may have to dive into more about, for example, if I got ML out, and also I got ML out over there, right? In the, let's say we talk about M1 and also M0. In that case, what kind of property can we prove about between these two versions? For example, Gauss strengthening is definitely one. And also invariant preservation. And also when we try to combine all the events in the concrete world together, it's about relative deadlock freedom, right? Also make sure you understand the concept over there. Yeah. So Wallet, I hope that's kind of answer your question. Yeah. Yeah, I think this diagram, don't stress over too much about this diagram. I think that one is really meant to help you understand how we relate, the concrete and the abstract events together, right? Oh, another one. That'll be a nice one. Question 3, okay? Let's say if I got IL out. Let's say I'm now talking about M1. The question could easily be, what would be the corresponding abstract events in this case? The skip events, yes. As we said in the class, well, there's another story to tell, right? So we say that for every new event in the concrete model, it has no corresponding abstract event, strictly speaking. However, based on the effects of that particular event, we can define according to the skip events in the abstract world, right? Okay, so basically new events correspond to the skip. Okay, and make sure you kind of go over the discussion over there in the class. Another thing I can mention now that I remember, okay, and we talk about whenever you got a new events in your concrete model, that means you got a possibility of deadlock or life lock. Which one? When life lock, right? Okay, possibility of life lock. And of course, I'm pretty sure you know what's the other way to describe life lock. What's the word? Starting with D. No, so we talk about life lock, right, which is different from deadlock. You should really tell the difference between life lock and deadlock, by the way. Okay, but what's the other way to call life lock? Divergence. Very good. Thank you. Yes. Yeah. So I can tell you that I try to organize the question in a way so when you turn to the front page, I mean the first few pages, those are more like a definition, understanding kind of question before you get to the more creative part. So I would say try to answer those as best as you can, maybe in the first half an hour. Try to do that. Okay, and overall, before I get back to the new events, I do want to give you guys a little bit more hints. Okay, I think I reviewed the exam myself earlier this morning and also yesterday. I thought it's a good exam. You really try to touch on many aspects of the course, which is good for us to see, really to see how much you have learned. But I think you will get very busy during the exam. Okay. Hopefully, you will still have maybe about 10 to 15 minutes at the end to maybe check your answer quickly. But I would say for those questions you really feel comfortable answering, don't assume you can actually go back and check. Maybe you want to spend more time on the more creative questions. That would be my suggestion. Okay. There are actually quite a good number of questions that will require some thoughts. So you definitely want to put more time into them. At the same time, really, even though you got 3 hours, but you get past very quickly. If you really struggle with a particular question for too long and you are not making any reasonable progress, I would say you may just want to abandon or pause and then put a mark and come back later, right? You really want to dedicate enough time for other questions too, right? That kind of strategy I thought you may have developed already, right? Okay, a little bit more. So we talk about the possibility of life lock or divergence. And there is a way for us to kind of measure your system to see if it is really divergence or life lock free. And what is that construct that we want to define for our system? So there is one construct in our system for which we try to use, let me say it again. There is a kind of construct for your system, and you use it to really try to prove that your system is like a lifelock or divergence free. What is that construct? Variance. Very good. Okay. Yeah. Okay, so you want to make sure for the variance, and there are two associated proof obligation related to variance. Make sure you know them very well. Okay. Typically, to really, once you can formulate these two proof obligation, they are not difficult to discharge. Either you can discharge it without any problem, or you can get to a point that you can easily conclude is unprovable, in which case your system is not really divergence free. Okay? And back in the introductory part, when we talk about variance, we also try to trace the evaluation of the variance. If you kind of remember, well, just roughly speaking, right? Let's say these are like event occurrences. And this will be the variance value, right? So you basically got something like this, something like this, something like this, and then like that, right? So you just have to remember, I'll put this as a question so you can check when you go back to study. Where we can get the variance expression value increased or flat. What kind of events can really make that kind of contribution, right? The blue part. So the variance value can either increase or stay flat. There's another category of events that's going to strictly decrease the value of your variance. That's another category, right? Just make sure you also review that part, okay? Okay, I think that's about what I want to say just for now. Okay, any follow-up or any new questions? Yes? It's a very good question. The question was, let's say I give you a sequence. Sequence could be something maybe you saw previously in the lecture, or maybe I simply modify the sequence by taking out some hypotheses or adding something, right? Let's say you're given a sequence over here. The question can be as easy as prove or disapprove the sequence. In that case, how can you know? You can get to a point that you can conclude. From there, I can say, oh, the sequence is indeed unprovable. In general, it's difficult. I agree. So this will be my suggestion. Okay. Go with your intuition about proving the sequence by following one path. Let's say, because you got to trust your intuition, right? Assuming that you have done enough exercises. If somehow, based on your intuition, you try a particular path, but somehow it gets to a dead end, in that case, can you simply conclude the sequence unprovable? I would say it might be too premature to actually make that decision. So let's say, if not able to prove the sequence think backwards about different ways of branching. Right? So basically, you want to see for all the inference rule that you have been taught, see if there's another way to really branch out for the sequence. I would say for all the proof questions you are given, there will be no inference rule that we haven't really taught. Right? So that should be the general rule. But I would say even more important, step number 0. Read the sequence hypothesis and go carefully first. to see what's really to be proved. Okay. I don't think the proof that you will be given in the actual exam will be too long. Okay. I would say the proof that we did in the lecture, that should be around the level of difficulty. Of course, I may not tell you how exactly it might be, right? Just get prepared. Okay. So Monica, does that kind of answer your question? Okay, let me say one more thing. Okay, I also got several emails from your classmates about this question. I think that's a really fair question. Let's say this. Let's say you got certain sequence over here on the left. You are thinking about to go from here to another sequence. You just want to apply the ARI, the arithmetic. I would say in some way this is a very powerful inference rule for us. Okay, I would say any inference, any step for which the justification is not really one of the inference rules that we have taught, very likely you can use ARI. However, I would say there are cases where ARI is really trivial. You don't need to do anything else. For example, let's say, if somehow I say A is a natural number, in that way you just put A larger than or equal to 0. That one, definitely, that's trivial. We don't need any further justification. All you got to do would be maybe just indicate very quickly to underline this, so TA would know. By applying ARI, you're transforming from this to this. Okay? This is a simple case where you don't need any justification. On the other hand, let me give you another example. Okay. Let's say, let me put them together side by side. Okay. Another one could be, let's say we got something over here. Okay, let's see. Again, the left and right. Let's say we got, let's say A larger than B, and then B larger than or equal to C, right? Of course, this one is very focused. You can easily see, but they might be spread out into different hypotheses. In this case, you can circle this, and then you do ARI, right? And then, so this one can be reduced into A larger than or equal to C, right? So I would suggest for this one here, this is not as straightforward as this one over here. So you may just want to put some side notes about why you believe this can be done for this transformation. I would say any step that's not really justified by the inference rule that you have been taught, most likely you can use the ARI. But in many cases, the transformation may not be exactly trivial. In that case, I would say always put an arrow besides the ARI and then put a little bit description over here about how to justify it. Okay? Now ARI, I think that's important. Okay. All right. All right, any other questions? Yeah, don't worry. Take your time, and then I will pause, and then see if you got any questions. Oh, of course, one thing, anything that came to my mind, I also mentioned to you. So in the actual exam, there are some questions they might ask you to specify in rodent syntax. And in some cases, it might ask you to write in the math form. So it will be done explicitly to actually instruct you about what you should really write. So just follow that. I'll give you one example. Okay. So for example, let's say in the math form, you might say for every, let's say x, and then you might say x is natural number. That means x larger than or equal to 0, right? And in rodent, I believe that's the universal quantification, right? And then x, a member of, that one, a member of, sorry, I may not be exactly right, but you see the point. right? So guys, correct me if I got any mistake. You guys should be better in rodent syntax than I am, right? Okay, please. In case I wrote something wrong here, don't copy that, but you really get my point. My point is, in the actual question, some of them does require you to write in rodent syntax. Some of them does require you to write in math form. Just make sure you know both, right? And I cannot emphasize more. For quantification, you should really know the rodent syntax and the math form. And what about, for example, relations and the different kinds of functions, right? And also the different operators. Of course, operator here can be set operator. How do you do intersection, union, subset? And also how do you do relational image or domain restriction, etc., right? Just review those. Of course, feel free to put them on your data sheets if you are worried that you might forget them. Okay? Oh, you mean, oh yeah, the exam question there, apparently that one, don't let it mislead you, right? I didn't really mean to mislead you. That's why I say it's only meant to be examples, right? Just for you to see, you might get some question like this, right? But you definitely should go over everything that we cover in the class. Definitely the 2 makeup lecture, the FTP case study, and also the remaining part for the second refinement. How you add the action, how you split the events, and how do you justify about the relative degree of freedom, right? Things like that. I think the exam itself covers quite widespread the coverage for the course material. Yes. Yeah, of course, also make sure you understand about nested quantification. Yeah. For example, how do you nest for all exist? And how do you nest exist for all? Right? Things like that. You might find them useful. Okay. Yeah, we still have time. But if you really would like to reserve your question like a one-to-one, I still have office hour afterwards. Don't be shy. You can still reach out to me. But let me know. Okay. It's really your time. By the way, did you guys put this formula here? M, choose N. You know what it is, right? Okay. Make sure you know how to do that. Okay. That might be a big hint, right? That's okay. As long as you know how to do it, I'll be happy. Don't mind giving you a little bit more explicit what you should really study for. Yes. Yes, you can bring calculator. That's not a problem. Yes, you can bring a simple one, not your mobile phone. Maybe your simple calculator. That's not a problem. Yeah. Just in case your classmate. I'm not too sure if I mentioned that in the exam guide. Maybe I did. Maybe I did not. But in case you're watching this recording, calculator. Okay. And you cannot bring your sketch paper. Okay. Because I already included that as part of the exam booklet. I give you 3 pieces of paper. I think that's more than enough. So you don't need sketch paper. Yeah, make sure you study everything for the course. I think it's a very nice way to really wrap up the course. I think that's nice. That's really the purpose of having a substantial exam at the end. Not very pleasant to think about, but it's a good way to push. I think the only thing that you didn't have to study is For your lab number 3, remember there's a part 2 about interacting with a road improver. This is the only thing I can explicitly say you don't need to study for that. I didn't put any question on that. Okay, that one I can tell you. Okay. If you're thinking about studying that, don't waste your time. Okay. Yeah, it's definitely worth reviewing a little bit about lab number 1, lab number 2, and lab number 4 about how you can really make use of the relational operators and how you can write invariant properties about the mathematical variables. I think it's definitely worth reviewing. Okay. Guys, any other questions? Yes. Of course. You mean the in-person lecture, right? Yeah. Okay. Give me a moment. Yes, I'll go there. Give me just one moment. Yeah, which one? This one here. Yes. Mm-hmm. On the right side. Oh, over here, right? Oh, I see. Okay. No, actually, this one here should include both the abstract and the concrete invariants.
Yeah. But when we say abstract, it's M1. But
oh. Let me see. Okay, I see. This part here. Okay, so this one here is the axiom from M0. They're sharing the same axiom. And I see what you mean. You're saying these abstract invariant, right? I see. Yeah. So when you let me clarify over there. Yep. Okay. Maybe I think the slide was right. Maybe I said it maybe not very accurate in the class. I'm glad you pointed out. Okay. So the idea would be whenever you talk about invariant preservation, for example, you can see we do the axiom, which is shared by all the 3 models, M0, M1, and M2. And when you try to lay out all the invariants, you can see some of them from model 0, some of them from model 1, some of them from model 2. They should all be included. Basically, the current model is a concrete one. And there will be 2, like a predecessor, like a parent models. They should be included as well, because sometimes they might be useful. Especially, for example, if you have to prove something later about maybe related to with n, in that case, you really need that abstract invariant from M0. So you should really include them too. Yes. Mm-hmm. Okay. Yeah, the makeup lecture that you were supposed to study, right? There were 2. One is about the FTP. The other one is about the remaining part for the M2, right? Okay. Of course, both of them are important in different ways. For M2, of course, including the parts, before the makeup lecture, I may ask you questions related to M2. Okay, so you want to make sure you really understand how M2, the details about M2 being a refinements. Okay. The FTP lecture there is really important to see how to manipulate sets and relations, which we didn't really do on the bridge controller case study. Especially if you look at the different ways, how we, for example, state the proof obligation for invariant preservation, right? So you can see now we actually involve some variable that's actually a function. In that case, how do you discharge about it, right? I may not ask you maybe specifically about the FTP. I could give you another new case study But the way they manipulate the sets and relation might just be similar. You need the foundation that you learn from FTP. So I think both makeup lecture are really important. Okay, both of them. Mm-hmm. Yes.
Could you go over how we can use the variance to measure new events compared to
Sure, sure. Sure. How about just maybe go a little bit like a higher level review, and then there's certain detail you have to go back to the lecture. Okay, how about that? Okay. Yes, we can do that. Let me just go back to, give me one moment. That's the makeup lecture part. Okay, bear with me. Okay, I think it's even before that. Oh, yes. Yeah, why don't we just go back to the first refinements, which is about the M1. And then we can just go over maybe the idea about variance when you talk about, right? Why don't we go over that? Oh, exactly here. Okay. Okay, good. Yeah. So I think that's the lecture from March 28th. Maybe you want to maybe go over some parts of that, for the recording. Okay. Okay. So are you more confused about the general idea about why we're using variance, or just about the technical part about how to measure that? Everything. Okay. Why don't we just go over about what you should know, the most important subtopics you should know about variance, and then you will fill out the gap. Okay, good. The most important thing, number one, why we are doing using variance is because given it's an arbitrary model, they might diverge or have some life lock. In which case, we actually got new events indefinitely occur or interleave, which will prevent from any old event to really get executed or just occur. In that case, it will simply correspond to a series of skip in the abstract world, like a BC weighting. Right? So that's how we started with. And there are basically two possible ways you can really discover divergence. The not so effective way is by looking at the model and then you try to come up with a trace that's going to illustrate an indefinite interleaving of the new events. So that wouldn't be so recommended because given another model, you may not be able to come up with such trace. Whereas maybe the model itself really diverge, you just cannot come up with a trace. So the more systematic way to do that is to have the variance, which is a way for you to measure about the occurrence of the new events. So I kind of sketched the idea over here. Okay, think about this part over here is about the occurrences of all the events over time. Okay, you started with some inits. You might have some old events, you may have some new events, different occurrences. So the idea would be whenever you got any occurrence of the new events, it's going to be measured as decreasing some integer expression, decreasing. If you're decreasing some integer expression, eventually you should really get to 0 at some point. And the idea about variance is, if you try to use the variance to do the measurement, once you get to 0, this point here, the guards for all the new events should be disabled at this point. And then the only way for this new event to be enabled again for their guards is for some old events to actually get occurred. In that case, it's going to increase the value of maybe the variance. In that case, they will be able to take place again. That's kind of the big idea. Okay. And this is a very detailed tracing about how we can measure the value for the variance. Right? You can see. Whenever you got any occurrence for the old events, it's going to increase the value of the variance. That one tells you how many new events you can actually take place consecutively. Once you get to 0 over here, the design of the guards of your events should effectively disable all the new events at this point. In that case, the only way for you to really take any new events to happen is after some old events happening. Right? Okay, and then you boil it down into two proof obligation. Okay, one is about the variance itself should be a natural number. Okay, because you can only get down to 0. You cannot go down anymore. And the second proof obligation is every time if you try to really take some new events over here, in that case, you should strictly decrease the value for the variance, right? Yep, that's basically what you have to know. Okay, all right. Yeah, understand why we have to use the variance and what's gonna be the approach to really to adopt if you don't have the help of the variance. And also, if you really use the variance, let's say the variance we consider in the class was 2a plus b, right? In that case, this one works. But what if we change this one to be a plus b? Would it work? If it works, you have to show that by proving these two. And if it doesn't work, you also have to make sure you find one unprovable sequence based on these two proof obligation, right? So in the exam, I might just give you some arbitrary variance and say, okay, now show to me that this variant will actually work. And how would you show it? You have to discharge the corresponding proof obligations. Okay? Yeah. Yeah, variant is, I can emphasize more, it's a very important topic. Okay. I think when you get to maybe 4315, the sequel to this course, most likely your professor will talk about if you try to implement some mission critical system, let's say you have some iterative algorithm. In that case, how can you be sure your loop is actually correct? And we also got an idea about looping variance and loop variance. I'm sure you have heard about looping variance back in 3101, right? It's actually some Boolean condition that should remain true, right? But loop variance, just an aside, it's not on the exam, right? Loop variance is very similar to the variant over here. How can you be sure your loop is going to terminate ultimately? You also try to use some integer expression to say how many iterations do I have remaining before it terminates. So that expression there must be a natural number. And every time you try to execute one more iteration, the variant value should really strictly decrease until you get to 0. And then it's about time for the loop to terminate, right? So these nice ideas are really there to help you to get some correct software, right? Okay. All right, guys, any other questions? Okay. Yeah, as I said, on Sunday, okay, it's not really early morning test. Make sure you eat lunch, right? Sleep well. And I cannot emphasize more. So the exam actually got a very good number of questions over there for you to really think about. So I would say, yeah, do your best. Yeah, for sure. Okay. Right. Yeah, I think still got 8 minutes, right? If you want to ask me more questions, you can ask now, or I'll see you in my office hour. Okay. Okay. Okay, I'll stop the recording now, and then if you still want to see me, I'll be there about 1:30. Okay, if you want to come a little bit earlier, 5 minutes earlier, feel free to knock my door. That's okay, and then we can talk. Okay. Thank you so much.